Swayam Prabha. Digital India. Educated India.
Welcome back to the course Mechanics of Solids. So, as we have seen in the last lecture that we were talking about equation of equilibrium and free body diagram. So, we are basically discussing a free body diagram with examples on modeling of typical supports and joints, conditions for equilibrium in 3D and 2D, friction, limiting and non-limiting cases. So, these are the things we are just covering in this particular chapter. So, basically in the last lecture we have taken couple of examples to show how you can draw the free body diagram from a complicated system, right. So, now as you have seen, most of the mechanical systems whatever you see in day to day life, they support, they have some support on the on some other kind of material, like say suppose if I want to have a beam that you generally see in day to day life in different civil engineering structure, that will be supported on say column, right. So, these are columns. So, they are supported on the columns. So, every system, if you think about in the last lecture whatever we consider two balls, right, which is resting in the in a can, right. So, the upper ball is getting support from the can as well as from the ball, and that is why the support reactions got developed, and we have seen that thing in the free body diagram. Similarly, the lower ball is getting the support from the can, so that it is resting in equilibrium condition. And similarly, we have shown when we are talking about the free body diagram of the can, then we talked about the support from the bottom of the can, because the can cannot fly, or can cannot be in the void space, right. It should have some support, so that it will give or it will satisfy the equilibrium conditions. So, now we should know what are the different types of support we generally encounter, okay, in mechanics. Okay. Apart from that, you have different other supports, but mostly these supports will talk about the or will cover the whole range of problems. Okay. So, let us talk about the support conditions for different mechanical systems. Support conditions. Okay. First one is, suppose I have one beam, okay, which is supported like that. Okay. So, these are rollers, fine. So, if I consider this is my xy plane, okay. So, this beam is spanning in xy plane, okay. So, this is the planar structure, you can say. In the z direction we are not considering at this moment. So, this support is known as roller support, as it is resting on rollers. Now, if I have this kind of support, then basically what will be coming to your mind? Now, if I say this is a support, support means it will try to hold the structure. Okay. So, this is the structure, the support will try to hold the structure in position. Suppose I am standing here, right, I am standing on the floor. So, floor is giving me the support, so that I am not going inside the ground. So, that is nothing but the support. So, every mechanical system, if you consider, you should have some support, otherwise it will not be stable. Okay. So, now if as I told you, I am standing on the floor. So, my weight is giving some action on the floor. So, floor is giving some reaction, equal and opposite reaction, okay, as per the Newton's law, and that equal and opposite reaction basically will be in the upward direction. Say suppose my weight is acting in the downward direction. So, the reaction will be acting in the upward direction. So, that means I am free to move in this direction like this, but I cannot move in the vertically downward direction, because the floor is giving me the opposite and equal reaction. What does it mean? That means if I restrict anything, any system or any component of the system, if I restrict that thing from any movement, so in that direction basically I will be getting some reactions. Am I right or not? Because I can move in the lateral direction or in this direction, right, in the frontal direction, because I do not have any reactions on those directions. Nobody is obstructing me, nobody is restricting my movement. So, that is why I am getting, I am not getting any reactions in those directions, but I cannot move in the vertically downward direction, because the floor is giving me the support, or floor is giving me some opposite reaction. So, for any support, it will try to restrict some movement and try to allow some movement. If it restricts some movement, then of course, you will be getting the reaction in those directions, and if it is allowing the movement in some direction, so you will not be getting any reaction. For this, from the discussion so far, whatever we are doing now, based on that we can say that. So, what we can say? We can say that a support will give me the reaction if it restricts the movement in that direction, and the support will not give me any reaction if it allows the movement in that direction. Okay, fine, fair enough. Okay. So, if that is so, this roller support, if you look at, I have rollers here. So, the movement of this beam in the x direction, that is the horizontal direction, is not restricted by the support. The support is not restricting the horizontal movement of the beam. Therefore, I should not get any reaction in that direction as per our discussion, or as per our say whatever we have agreed. Okay. But if you look at this beam cannot move in the vertical direction, vertically upward or vertically downward. Of course, this is a simplified figure. Generally, one more roller support is generally put on the top, so that the vertical movement either in the upward direction or in the downward direction, that means either in positive y direction or negative y direction, is completely restricted. So, if the movement is restricted in y direction, then what should I get from the discussion? That I should get one reaction, right. Okay. Now, another thing is that suppose I am putting some load on the beam. So, this beam, suppose if you consider this is the beam, this part is the beam, this is the support. Now, this support is not allowing me the vertical movement, but it allows me the horizontal movement, but at the same time it allows me the rotation of the beam. So, beam can rotate with respect to this point, it can rotate, right, like this hinge. So, this hinge basically will give me the rotation. So, if it gives me the rotation, so, and rotation generally happens due to the moment. So, what we can get from this support, because this is allowing the horizontal movement. So, there is no horizontal reactions. It allows the rotation, so therefore, no moment reaction, but it does not allow the vertical movement. So, therefore, there must be some vertical reaction. So, once I want to show the free body diagram of this beam, so the free body diagram of the beam will be like this. So, this is your beam. So, free body diagram means you want to separate the beam out from the system, that means you are replacing the support by putting some externally applied forces. So, what are the forces will be there then? Only the vertical reaction. So, this is the typical behavior of a roller support. So, whenever you will be encountering with roller support in this particular course, immediately it should come to your mind how the reactions will be developed at the support. Okay? Because it is allowing the horizontal movement, therefore, no reactions in the horizontal direction, it is allowing the rotation. So, therefore, no moment reaction at the support, but it does not allow the vertical movement. So, therefore, I should get one vertical reaction. Okay. So, similarly, the second type of support is hinge support. Take another beam. So, this is your hinge support. So, what is the speciality of this support? If you look at this support is looking like roller support, but it is not the roller support. Why it is not the roller support? If you look at this support, it will not allow any movement in the horizontal direction, which is not like the case whatever we discussed previously for the roller support. So, it restricts the horizontal movement as well as it restricts the vertical movement, but what about the rotation? It allows the rotation, right. That is why I mean you generally see this kind of support in the door, right. If you want to open the door or if you want to close the door can be rotated, right. Door can be rotated with respect to the hinge at the end, which is attached to the frame, door frame, right. So, door can rotate, but it will not come out from the frame or it will not go down from the frame. So, this is a typical example of hinge support. Okay. So, if I want to draw the free body diagram of this beam, so how should I draw it? So, this is the beam. So, it restricts horizontal movement as well as vertical movement. So, therefore, I should get two reactions R y and R x. And what about moment? There should not be any moment reaction because rotation is allowed. Okay. Fine. So, next type of support is next type of support is fixed support. Okay. Next kind of support is fixed support. So, this support does not allow horizontal movement, does not allow vertical movement as well as does not allow any rotation. So, therefore, I should get, because all the movements are restricted. So, therefore, I should get all the reactive forces. Okay. So, if I want to draw the free body diagram as per our discussion, I will get vertical reaction, I will get horizontal reaction, and I should get the moment reaction. Okay. So, all the reactions, because it is not allowing me the rotation, it is not allowing me the vertical movement as well as the horizontal movement. So, therefore, I should get the components of all the reactive forces here. Okay. So, now this fixed support you generally see in your day to day life, like a beam is having the support on the column. So, beam column support or beam column junction you might have seen in your building or in any civil engineering structure. This beam column structure is generally defined as the fixed support. Okay? And where you get this roller and hinge support, have you ever seen this? Have you ever seen any railway truss bridge or the classical example of the Howrah bridge or something like that? So, there if you really look at the supports at the bottom, so you might get this kind of supports. So, I will show you the typical picture of this kind of supports. So, if you look at this figure, so this is your hinge support. If you look at this, okay, this is a huge bridge truss. Truss will be coming later on. Okay, what is truss and how we can define truss and how we can solve the truss. So, those things will be coming later on. But you might have seen that is railway bridge, some steel truss railway bridge, or the classical example is the Howrah bridge. Okay, the Howrah bridge, classical example of the Howrah bridge. So, that steel structure completely made of steel. Okay. So, there you might have seen, okay, if you carefully look at the supports, okay, you might see this kind of supports. So, this is known as hinge support. If you look at, this is known as hinge support. Okay. It looks like whatever I showed you just now, right, from the frontal elevation. Okay. This is the typical example of roller support. If you look at this, it will try to allow the movement in the horizontal direction, but it will not allow the movement in the vertical direction. This is the typical example of the roller support. It could be huge. I mean, it is not the small thing, right? It could be huge. It should sustain the load whatever is coming on that roller, right. So, see, this is the beam, some beam or some structure which is carried by this roller support. So, it will allow the movement in this direction, but it will not allow any movement in this direction. So, this movement is not allowed. Okay. So, these are some typical photos, so that you can absorb or you can understand that what are the different types of support we are talking about. Okay. So, now with this brief background of the support conditions, okay, now we will try to draw the free body diagram of a typical structure. Say, let me draw that. This is one hinge support. This is a roller support. So, this is A. Some load R is acting at the bottom. This point is B, this is C, D, E and F. Okay. So, this is a kind of frame you might have seen, made of steel or wood or whatever. All these members, so these are joints. Okay. These are all joints. Now, how many members we have in this frame? We have AD, one member, DE, another member, EC, another member, DB, another member, EB, another member, and BF. So, 1, 2, 3, 4, 5 and 6, there are 6 members which are connected by some frictionless pin, which are connected by some frictionless pin. I mean, we are assuming that thing, we are idealizing that system. Okay. So, this all joints are made of frictionless pin. It could be pin joints, it could be rivets, okay, or it could be bolted. You might have seen that thing in different frames, right, frame structure if you look at. Anyway, so we are not going to analyze the frame right now. We will see how we can analyze the truss. At that time we will talk about this thing in more detail. However, I want to draw the free body diagram of this system. Now, if you look at this system, generally these members, okay. So, what are these members? AD, BC and all these 6 members, okay. So, these 6 members, how it will behave and what are the different forces it will take. So, those things we are not talking about at this moment, because we are not equipped to do that at this stage. But I can draw the free body diagram, because right now I know the support conditions. So, if I want to replace these supports, I know how to replace those things, okay, and then I can draw the free body diagram. So, if I want to draw the free body diagram of the whole frame, a BD of frame, then basically this is the frame, okay. So, this is A, this is C and this is D, this is E, this is B and this is F. So, this is the whole frame, I am taking it out. So, when I am taking it out from the actual system, then it should be the support conditions must be replaced by the forces. So, in this hinge support, what are the forces we will be getting? The reactive forces, one horizontal and one vertical, right. So, if I say this is my xy plane, so I can simply write, I do not know the direction. So, do not think about the direction too much. You may ask me why I am showing Ax in this direction. Let it be in the opposite direction, I do not have any problem, okay, because I do not know the actual direction. So, that will be coming later on when we will be actually analyzing the structure, okay, the correct direction. So, right now this direction is arbitrary, I am just putting that thing arbitrarily, okay. You can choose different directions, there is no problem, but only thing is that only thing you have to remember that we will come to that point, okay. So, we are replacing the reactive forces here. Similarly, at C, this is the roller support, so only vertical reaction, right, only the vertical reaction, okay. And at point F, so before that this AB will be having weight. If I consider the weight of the member, AB is a member, say, okay, and DE is a member. Well, I mean in the problem what I am seeing here in the problem I am considering AB is one member, another one member is BC. So, BC is the whole member, AB is a whole member. So, they are connected by DE at these 2 points. So, AD, BD they are not separate members. Okay. So, as it is shown in the problem, so AB is a complete member. So, in the previously whatever we talked about. So, now basically we have AB one member, BC another member, DE another member. So, 3 members and BF. So, 4 members instead of 6. So, whatever we just talked instead of 6 basically depending on the problem. I mean you can have different members, you can have 6 members, but at this problem whatever I show that these are 4 members only. Anyway, so that is not a problem. So, if you consider AB as a whole member, so the weight of the member AB, that is WAB, can be assumed to act along the center of gravity of the member. Fine. Similarly, WDE is acting here. Similarly, WBC is acting here. Okay. And at point F, you have already force R plus WBF. So, this is the free body diagram of the whole frame. Now, I want to draw the free body diagram of individual members. I mean, so from the macro system, I am coming to the micro system, then from the micro system, I am going to the nano system, something like that. If you try to map like this, okay. So, now I want to draw the free body diagram of each and individual member. Let us draw that. So, this is my AB member, okay. I have AX, AY here, okay. Now, this is a joint, as I told you, B is a joint. Now, I do not know the direction of the force at this joint, because the joint will develop some support, because the joint is giving some support, right, for the member AB. AB is getting held by these 2 supports A and B, right. So, at A I have defined the forces, because that is the hinge support. This B is a pinned support or the some joints. In the joints I do not know the direction of the force, in which direction it will move. It may along AB, it may take some other direction, I do not know, line of action of the force is not known, but I can resolve whatever line of action is there, but I can resolve that force in 2 components, one is along x direction, another one is along y direction. So, that thing I can simply show By and Bx. Again I am telling you repeatedly that I do not know the direction of Bx and By. Bx could be in this direction, By could be upward direction, that could be, but I do not know. I am just writing that thing arbitrarily. That will be coming from the analysis. When you are analyzing the actual structure, then it will be coming automatically. Now, at point D, so DE, that member is getting supported at point D and E. So, at point D we will be getting some reactive forces. Again I do not know the line of action of that force. So, I can resolve simply dx and dy, and of course, I can use the different color for the weight. Of course, I have WAB. So, this is the free body diagram of the member AB. Okay. Similarly, I can draw the free body diagram of member DE. This is the member DE. Okay. In that member, so here actually one thing you have to remember. Now, at point D, because it is in equilibrium, so the whatever direction of dx is shown here on this member, it should be exactly opposite and equal, otherwise it will not nullify or cancel each other, right. So, this thing only you have to, this is your dx and dy I have shown vertically downward. So, it should be upward. This thing only you have to remember. Now, if you choose dx here in this direction, here dx will be in this direction. So, that only you take care, rest of the things will be coming automatically from the analysis, you need not to think about that. Okay? So, do not scratch your head by selecting or for selection of the direction of the forces. Okay? Similarly, for E, I am showing here Ex and Ey, and of course, the load is acting W D. Okay? Anyway, so I will stop here today. So, in the next class we will continue with the free body diagram of the other members. Thank you very much.